This is SpaceTime, Series 28, Episode 106, for broadcast on the 3rd of September 2025. Coming up on SpaceTime, Europe's JUICE mission back on track for its flyby of Venus following earlier problems. NASA's Psyche spacecraft calibrates its onboard cameras as it continues on its mission to Jupiter. And scientists have developed a way to use moon dust to create water, oxygen and fuel. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The European Space Agency's Jupiter Icy Moons Explorer spacecraft JUICE is still on track for its gravity-assisted close flyby of Venus following a successful resolution of a spacecraft communications anomaly which temporarily severed all contact with the Earth. JUICE is on its way to orbit and study the three Galilean ice moons of Jupiter, Ganymede, Callisto and Europa. These planetary mass moons are being targeted because they're thought to have significant bodies of liquid water beneath their frozen surfaces, and that could make them potentially habitable for extraterrestrial life. The spacecraft's anomaly issue first emerged during a routine ground station pass back in July. It temporarily disrupted JUICE's ability to transmit information about its health and status back to Earth. Mission managers at ESA's European Space Operations Centre in Darmstadt, Germany, worked with JUICE's manufacturers at Airbus to troubleshoot the problem and successfully restore communications in time to prepare for the upcoming planetary encounter with Venus. The anomaly began when ESA's Deep Space Communications antenna in Spain failed to establish contact with the spacecraft at the expected time. And attempts to re-establish contact with the spacecraft using ESA's New Norcia station near Perth also failed, confirming it was an issue with the spacecraft rather than with the ground stations. With no signal and no telemetry, mission managers feared JUICE might have entered survival mode, a sort of last resort configuration triggered by multiple onboard systems failures. Now, in such a state, the spacecraft would spin slowly, sweeping across Earth once every hour. However, no such intermittent signal was detected. JUICE Spacecraft Operations Manager Angela Dietz says losing contact with the spacecraft is one of the most serious scenarios you can face. With no telemetry, it's much more difficult to diagnose and resolve the root cause of an issue. Initially, attention turned to the communication subsystem. Engineers suspected either a misalignment of JUICE's medium-gain antenna or a failure in the signal transmitter or amplifier. So they considered two recovery strategies: waiting for the next automatic spacecraft reset in 14 days' time, or sending commands blind into space in the direction that JUICE should be at, hoping that they'll be received by one of the backup low-gain antennas on the spacecraft. Thing is, waiting 2 weeks for a reset would have meant delaying some important preparations for the Venus flyby. On the other hand, blind commanding was a challenge. JUICE was around 200 million kilometres from Earth and located on the other side of the Sun. It took each attempted rescue signal 11 minutes to reach the spacecraft, and mission managers then had to wait another 11 minutes to determine if they'd been successful. 6 attempts to steer the medium-gain antenna back towards the Earth were all unsuccessful, but recovery efforts continued, lasting almost 20 hours, and focused on manually powering up JUICE's onboard communication systems. But eventually a command did succeed in reaching JUICE and triggering a response. That command activated the signal amplifier, which boosts the strength of the signal which JUICE sends towards the Earth. Once contact had been re-established, JUICE was found to be in excellent condition. No systems had failed, and all telemetry was nominal. It seems the root cause of the problem was a software timing glitch. See, the software function that switches the signal amplifier on and off relies on an internal timer. And this timer is constantly counting up and restarting from zero once every 16 months. Now, if the function happens to be using the timer at the exact moment it restarts, then the amplifier remains switched off and JUICE's signal is too weak to be detected from Earth. ESA is now developing workarounds to ensure it doesn't happen again. With the anomaly behind them, JUICE mission managers are now turning their attention to the Venus flyby, which is the second of 4 planned gravity assists for the spacecraft. JUICE has been designed for the cold, dark environment of Jupiter, but it still needs to cope with the intense heat of the environment near Venus. So in order to protect its sensitive components, the spacecraft uses its main high-gain antenna as a sort of thermal shield. Now, due to thermal constraints, its remote sensing instruments can't be active during the flyby. The thing is, to have gone directly to Jupiter without the flybys meant JUICE would have needed to leave the Earth with a much higher velocity, around 11 kilometers per second. However, at almost 6,000 kilograms, JUICE is one of the heaviest interplanetary spacecraft ever launched. And with such a massive payload, its Ariane 5 launch vehicle could only provide an escape velocity of around 2.5 kilometers per second. And so that's why the spacecraft's using 4 gravity assist maneuvers in order to pick up the rest of the speed needed. JUICE will use the gravity of Venus to bend its orbit around the Sun and gain speed relative to the Earth without using fuel. The Venus flyby will give JUICE a significant boost. And when it next encounters Earth in September 2026, the spacecraft will have reached the required Jupiter transfer velocity of 11 kilometers per second. But Jupiter won't be in the right place to send JUICE out towards it just yet. So JUICE will use the flyby of Earth in 2026 to further fine-tune its trajectory. Then, after one more orbit around the Sun, the spacecraft will return to Earth for a final flyby in January 2029. And this will place Jupiter in the right transfer trajectory for intercepting Jupiter in July 2031. This is SpaceTime. Still to come, NASA's Psyche spacecraft calibrates its onboard cameras, and using moon dust to create water, oxygen and fuel on the lunar surface. All that and more still to come on SpaceTime. NASA's Psyche spacecraft has successfully calibrated its onboard cameras as it continues on its journey to the metal-rich asteroid which shares its name. Psyche was launched back on October the 13th, 2023. Its mission is to explore the origins of planetary cores by orbiting and studying the metallic asteroid 16 Psyche. The spacecraft will arrive at Psyche in 2029. The asteroid is around 253 kilometers in diameter and contains about 1% of the total mass of the main asteroid belt between Mars and Jupiter. Several possible origins have been proposed for Psyche. The earliest is that the asteroid is an exposed metallic core resulting from a collision that stripped away the crust and mantle of what was originally a much larger differentiated parent body, some 500 kilometers in diameter. However, this idea has fallen out of favour of late because mass and density estimates are inconsistent with the idea of a remnant core. A second hypothesis is that Psyche was disrupted and gravitationally reaccreted into a mix of metal and silicates. Now, if this is the case, it may well be a candidate for the parent body of a class of stony iron meteorites. A third and now most favoured hypothesis is that Psyche could be a differentiated object just like the dwarf planet Ceres and the asteroid Vesta, which are also both located in the main asteroid belt. But Psyche experienced a sort of iron volcanism, also known as ferrovolcanism, while it was still cooling. Now, if that's true, the model predicts that metal would be highly enriched only in those regions of the asteroid containing relic volcanic centres. And this hypothesis is being supported by radar observations. As for the Psyche probe, well, it looked back at the Earth and Moon, silhouetted against the velvet blackness of space, capturing some iconic images from 290 million kilometres away during one of the probe's science instrument checkouts. On July the 20th and 23rd, the spacecraft's twin cameras captured multiple long-exposure images of the two bodies, which appear as little more than dots, sparkling with reflected sunlight in the constellation Aries. The multispectral imager instrument comprises a pair of identical cameras equipped with filters and telescopic lenses to photograph the asteroid Psyche's surface in different wavelengths of light. You see, the colour and shape of a planetary body's spectra can reveal details about its composition. When choosing targets for imager testing and calibration, scientists look for bodies that shine with reflected sunlight, just as the asteroid Psyche does. They also look for objects that have a spectrum that they'd be familiar with, so they can compare previous telescopic or spacecraft data from those objects with what Psyche's instruments are observing. Earlier this year, Psyche turned its lenses towards Jupiter and Mars for calibration. Each has a spectrum more reddish than the somewhat bluer tones of Earth. Those checkouts also proved successful. But the checkouts will continue because they need to determine whether the image's performance is changing, so scientists use them to compare data from different tests. That way, when the spacecraft finally does slip into orbit around Psyche, scientists can be sure that the instrument behaves just as expected. Psyche Imager Instrument Lead Jim Bell from Arizona State University says mission managers may also decide to image Saturn and the asteroid Vesta in order to continue to test the images. Now, the imager wasn't the only instrument that got a successful checkout. Scientists also put the spacecraft's magnetometer and its gamma-ray neutron spectrometer through a series of tests, something they do every 6 months. Psyche's next big milestone will be the flyby of the red planet Mars. That's slated for May 2026. There, it'll use the planet's gravity as a slingshot to help fling the spacecraft towards the asteroid Psyche. And that will mark Psyche's first of 2 planned loops around the solar system. This report from NASA TV.
I remember 2 Voyager missions launched in 1977. Shortly after launch, they turned around. They got the Earth and the Moon in the same picture. I've just been fascinated with imaging from deep space missions ever since. And I've been very fortunate to be able to create some of those pictures.
Psyche is what's called an M-class asteroid in the main asteroid belt between Mars and Jupiter.
It's the 16th asteroid discovered back in the 19th century. And we think that maybe it's the remnants of a planetary core.
All of the missions I've worked on had some sort of an imaging device.
Isn't that the first question that everyone asks? What does it look like? And so I've been dreaming about this object now for over a decade, and by then it'll be 2 decades I've been dreaming about this object. And then to see what it really looks like, what's more exciting than that?
For Psyche, we know it's going to be a relatively dark object. So we have to have an instrument that can see in that sensitivity with the dark surface and still be able to resolve the features that we're looking at.
The cameras on Psyche, we call them the Psyche multispectral imagers. They're a pair of identical cameras. They're a pair for redundancy, just in case we have a problem with one, we've got the other one.
And with stereo, we can build what's called a digital terrain model, the surface of Psyche, which we're very interested in knowing at a high resolution. Using the different filters, we actually can infer geochemistry of the surface. We can also associate it with the gamma ray and neutron spectrometer data set to sort of really drill down into the composition of the asteroid.
We'll also take pictures farther out into the infrared where these sensors are still sensitive and where we can get a little bit more information about the kinds of rocks and minerals on the surface. One of the other functions besides science for the cameras is that they are our navigation cameras as well. This technique that was invented back in the 70s called optical navigation. Take pictures of stars and star fields, kind of like looking at a sextant on a ship hundreds of years ago. The same process is used in modern space missions as well.
The instrument's actually being built by a company called Malin Space Science Systems. They built the LRO camera, they built Mastcam, they built Mastcam Z, they've built numerous other cameras that have flown to Mars. And they do the final fabrication and quality control before then delivering that instrument to JPL.
No deep space camera system like this has ever been built. However, the components that go into the cameras all have a lot of experience in space, a lot of what NASA calls heritage.
When we get to Psyche, we'll go into orbit. The imager will primarily work during orbits A and B to get the images, to characterize the surface features, to make the topographic map, and to get the color images, which will hint at the composition.
Standard plan is that we're pointed straight down and we're snapping pictures as the asteroid rotates underneath them.
Usually the most important image that everybody gets excited is that first image that we acquire that you get back.
We are super committed on the Psyche project, from PI, Lindy Elkins Tanton, all the way down to sharing this experience with the public. I think the only thing we know, and that's based on NASA's 50, 60-year experience now, is that it's not going to look like what we think it's going to look like. And it's going to be really interesting, whatever we find.
And in that report from NASA TV, we heard from Psyche Imager Instrument Lead Jim Bell, Psyche Principal Investigator Lindy Elkins, and Psyche Science Data Center Manager Ernest Cisneros, all from Arizona State University. This is SpaceTime. Still to come, using moon dust to create water, oxygen and fuel on the lunar surface. And later in the science report, A new study warns that years of repeated exposure to heat waves could accelerate aging. All that and more still to come on SpaceTime. Scientists have found a way to create water, oxygen and methane fuel using moon dust, astronauts' breath and sunlight. Transporting supplies from Earth to any future lunar base will be expensive because the greater the mass of cargo on a spacecraft, the harder the rocket has to work in order to launch into space. So, being able to produce water, oxygen and methane on the moon would save a lot of money. And this could open up new space science possibilities. However, a report in the journal Jill points out that photothermal technology has only ever been tested in the lab. It'll be far more complicated to operate in the lunar environment, where they need to contend with extreme temperature changes, as well as radiation and low gravity. This is SpaceTime. And time now to take another look at some of the other stories making news in science this week with the Science Report. A new study warns that rising levels of plastic waste are now breaking down in every part of Earth's land, sea and air environment, and that's leading to a proliferation of micro and nanoplastic pollution, which is posing a serious risk to all the planet's life forms. The findings by scientists at Flinders University show that chemical leakage is adding urgency to calls for a robust World Plastics Treaty. The authors have compiled a scientific policy submission for the United Nations for a new treaty in order to manage plastic production and its waste. A new study warns that years of repeated exposure to heat waves could be accelerating the aging process. The findings, reported in the journal Nature Climate Change, show the problem was especially significant for manual workers, rural residents, and people from communities with fewer air conditioners. The authors analysed data from 24,922 adults with an average biological age of 46.3 years who were living in Taiwan, and they then assessed how heat waves were influencing ageing in the group. They found that repeated exposure to heat waves increased average biological age. The study showed that while participants appeared to adapt to heatwave conditions over a 15-year period, the harmful health effects did not disappear. Canadian scientists say owl-like robots called Lunar that were originally given to 20 families to help their children learn to read in 2021 didn't end up on the scrap heap once the mission was completed, but instead became, at least in some cases, valued members of the family. A report in the journal Frontiers in Robotics and AI examined what happened to 19 of those families in 2025. The authors found that 18 still had Lunar, many were still charging it, and one child even referred to the reading bot as her little brother. Some parents even admitted keeping Lunar more for their own nostalgia than for their kids. The authors say their study shows that even a simple robot can become part of a family's symbolic life. It means designers and researchers will need to think of a robot's lifespan not just in terms of months, but in years. Google's long-awaited Pixel 10 has finally hit the stores, and its new AI capabilities are the headline feature. With the details, we're joined by technology editor Alex Zaharov-Reutt from Tech Advice Start Life.
Google has launched new phones, the 10th generation of its Pixel phones, its fourth watch, its third foldable. And obviously you've got faster processors, better cameras, more durable casings. But the real star of the show is the improved AI capabilities. Let me tell you about a couple of features. One is a camera coach. So you're taking a photograph of something, but you're not a professional photographer. And wouldn't it be nice if your phone could say, ask the subject to move a little bit to the right or to the left? Or how about you move in a bit closer? And you've got AI coaching you. But that's just one aspect. Another aspect that is unique to the Android world, so not even Samsung and other providers have it yet, not even older Pixels, and certainly Apple, which made promises about this sort of thing back at Worldwide Developer Conference last year. They haven't been able to deliver this either. Google calls this Magic Q, and this is their AI assistant that is going into overdrive to bring you information right when you need it. So an example, let's say that you have to change a booking for a hotel or a restaurant, and you're on the phone with that hotel or the restaurant. Now, wouldn't it be nice if the details of the booking would appear right on the screen as you're on the phone? What about when a friend is asking you what's the address of the venue that we're going to on the weekend. Now, that address is in your messages or in your email. Wouldn't it be nice if that information could just be surfaced right then and there, and then you can hit the button and it will be sent? So there's lots of little ways that your phone can, through the power of AI and all the interconnected apps, surface helpful information to you at the exact moment you need it. At the moment, it's an exclusive. They haven't said when older Pixels will get it. They haven't said when Samsung and others will get it. But clearly, at some point, they will.
Well, that's Google's side. What about Apple?
Yes, well, they normally launch phones at this time of the year as well. So what we have here is the iPhone 17 range, which might be called the iPhone 26. We don't know yet. We do know that the new iPhones and iPads and Apple Watches and Macs and all the previous ones that are compatible at the moment with the newest operating system will get iOS and iPadOS 26, which has that glassy, see-through, transparent look, which is preparing us for a world when we're all wearing augmented reality glasses, and we do not want to have giant interface elements blocking our view. Even if you're looking at something, you still want to be able to see behind it and then get rid of those interface elements so that you're looking back at the real world. And I've been using the beta version of iOS 26 on my iPhone now for some months, and it's fantastic. And I've shown it to people and they're going, oh, what phone is that? You know, they can see it's an iPhone, but they don't recognize interface. And when I tell them it's the beta version of iOS 26, they are excited to try it. So Apple will no doubt have some surprises. We're supposed to have big redesigns for the iPhone. And then come IFA, the big tech show in Germany that's on every year, and there's going to be big announcements from Samsung. We'll have more to say about those in the next couple of weeks, but it's smartphone launching season. We've had launches from Samsung earlier in the last couple of months with their folding phones. There's going to be new devices from Samsung in September. There's new devices from Google available in stores right now. And of course, the big daddy, Apple, with their launches September 9 in the US.
It's Alex Sahara-Vroyd from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.